The University of Louisville presents Aviary Manufacturing and its multi-tool submission for this year's competition.
Our brainstorming process began as we decided to watch last year's competition videos. We were set on improving our school's tool from last year's competition and decided to contact Brandon, who kindly agreed to give us feedback on what we could do better. And so, what began as an iteration on U of L's tool last year grew into a unique design to overcome our peers' challenges.
Our initial design focused on having an expanding body so that each tool could fully utilize its space without interfering with each other. It was also difficult to hold when it was expanded. Our second major prototype changed the hinge for a self-supporting dovetail-like joint. The design was an improvement, but after showing our faculty advisor, we saw that it would still have issues when printing.
Alright, here's our tool. What do you think?
Looks like something you'd find in Minecraft.
This leads to our final iteration, which effectively hides some of the tools inside of the handle that can be opened during use. When opened, the internal tools have a longer lever arm, allowing the user to apply more torque than would otherwise be possible on our previous design. We incorporated the bottle cap opener into the guard of the seatbelt cutter to save space, and finally earned the approval of Dr. Burfield.
We then moved on to running finite element analysis simulation on our tool to see how it would handle different loads, basically checking where it might bend, break, or deform so we could improve our design. For this design, we were particularly interested in the performance of the hammer, the seatbelt cutter, the wire cutter, and the hinge, which all performed very well with a minimum factor of safety of 1.29. Once we were happy with our plastic prototypes, we moved on to metal, setting up the EOS 280 and manufacturing our tool using laser powder bed fusion. With an estimated printing time of less than 6 hours, we were pretty happy with this print-in-place process inspired by our peers from last year. Until our first challenge, a power outage, set us back by a little bit. And so after a second round and this time successful additive manufacturing process, we got our tool out of the build plate using wire electrical discharge machining. Once out of the EDM, we moved on to post-processing, beginning with the removal of residual metal powder by vacuuming the tool as well as cleaning it with IPA. This was followed by auto removal of the supports and using a shot peen to enhance the fatigue life of our tool and preventing corrosion by inducing compressive surface stress. During testing, we were very satisfied with the overall functionality of our tool, with the Phillips head and flat head working perfectly. We were also very happy with the hammer, which performed well even at this pocketable size. And fitting a 1/4 inch Allen as well as attaching our 1/4 inch socket extension was also successful. The most fun part of testing was testing the window breaker. However, the best for last came about when the seatbelt cutter worked and joy filled the room with the realization we had made Brandon proud. And what better way of ending our testing than with the bottle opener, which also doubles as the seatbelt cutter blade guard, so we could enjoy this non-sponsored drink.
Much better, much better.
We'd like to thank America Mix for the opportunity of participating in this competition, as well as our faculty advisor, previous peers, and current team members. And thank you for your audience.